What you are seeing here is a class taught at Tropic Air in Belize, focused on avionics basics, troubleshooting, and wire repair. It reflects the kind of practical technical instruction Deep Blue Avionics is committed to building and sharing. But this video is not only a look back at one class, it also marks the beginning of a broader teaching effort, one that will continue through additional classes and through upcoming courses on YouTube and social media. The course itself centered on avionics basics, troubleshooting, and wire repair. And that makes it a strong starting point for this teaching front, because it introduces the kind of systems thinking, wiring discipline, and troubleshooting logic that aviation maintenance depends on. Aviation maintenance depends on more than knowing parts and procedures. It depends on how technicians think. A class like this matters because it helps build a disciplined approach to technical problems. Understand the system, verify the fault, interpret the data correctly, and make the repair using the right methods. That is the kind of foundation that improves troubleshooting accuracy and strengthens maintenance culture over time. This course works as a practical introduction because it focuses on real avionics fundamentals, troubleshooting logic, wiring, wire repair, and connector repair. This class focused on core avionics subjects that are directly relevant to everyday aircraft maintenance work. The training content covered basic avionics principles, weather radar fundamentals, troubleshooting, wiring diagrams and schematics, EWIS, wire repair, and connector repair. In other words, it was not limited to one narrow fault example. It introduced an entire troubleshooting mindset built around system understanding, signal tracing, and correct repair practice. One of the foundational lessons in the class is that the basic operation of a system is often the same regardless of aircraft type because equipment is designed and approved to standards. That matters because once a technician understands how a system works at the core level, that knowledge becomes transferable across different aircraft and installations. This is one of the most important strengths of technical training. It helps move beyond memorizing one airplane and toward understanding the logic behind the system itself. The class uses weather radar as a practical system example, and that is a smart teaching choice. It explains the main components of the radar system and how the system works at a basic level. That gives students more than just terminology. It gives them a mental model of the system, which is essential before troubleshooting begins. When technicians understand what a system is supposed to do, they are in a much better position to understand what has gone wrong. A strong theme in the class is that troubleshooting must begin with clarity. The process starts by understanding what is actually being reported, verifying the indications, and running the proper test of the system. The class also highlights the difference between a fault and a failure, and why that distinction matters when interpreting test results. One of the most valuable ideas in the presentation is that a single issue can create multiple fault indications. That is why troubleshooting must be approached one indication at a time, beginning with the easiest and most direct path. The message is simple: think first, then act. Another major part of the class is learning how to read the system on paper before touching the aircraft. Wiring diagrams and schematics help technicians understand how components connect, where signals begin and end, what wires are involved, and how a fault can be isolated logically. This matters because accurate troubleshooting depends on reading the aircraft's technical information correctly, not guessing based only on symptoms. A technician has to be able to trace the system both physically and electrically. The class also covers EWIS, or Electrical Wiring Interconnection System. This is an important topic because it reinforces that wiring is not just a bundle of conductors hidden behind panels. It is a critical part of the aircraft's system architecture. The class also emphasizes cleanliness in work areas, contamination control, and proper work discipline around electrical systems. That is important because avionics reliability depends not only on diagnosis and repair, but also on how the technician works in the area. The wire repair section of the class is especially practical because it focuses on decision-making. Before attempting a repair, the technician has to determine whether the wire run is short enough to replace, whether the damage is accessible, whether the correct tooling and materials are available, and whether the repair can be completed properly within the available time. This reflects real maintenance thinking. The question is not simply whether something can be repaired. The question is what the correct repair path is under the actual circumstances. The course also reinforces that the quality of the repair depends on the quality of the method. Correct tooling, correct materials, and correct standard practices all matter. This is one of the most useful lessons in aviation maintenance because good work is not improvised. It is performed using approved methods and repeatable procedures. That is how reliability and airworthiness are protected over time. Later sections of the class move into connector repair. This is where attention to detail becomes especially important. The class walks through the logic of identifying the connector, understanding the pin arrangement, gathering the right tools, removing wires correctly, preparing contacts, making the crimp properly, inspecting the work, reinserting the contact, and verifying that the connector is assembled correctly. This sequence is valuable because it shows students that precision work is not one big step. It is a series of small, correct steps. One of the best lessons in the class is that the job is not done when the suspected fix is made. After repair, the work has to be verified. The wire has to be checked again. The system has to be powered correctly. Circuit breakers have to be monitored. The system has to be retested. And the technician has to confirm that the original fault is gone and that no new issue was introduced during the repair. This is one of the clearest maintenance messages in the class. A repair is only complete when function is verified. This works well as a starting class because it introduces the type of technical thinking everything else builds on. It covers system logic, troubleshooting flow, wiring interpretation, repair discipline, and retest methodology. In other words, it is not just teaching one task. It is teaching a way of approaching aircraft maintenance problems. That makes it a strong foundation for the broader teaching front. What was previously taught at Tropic Air in Belize does not have to remain a one-time class. This video helps show the direction going forward: more practical technical instruction, more structured aviation education, and more content that explains real maintenance thinking in a way technicians, students, and operators can use. Some of that will happen through future classes. Some of it will happen through upcoming courses on YouTube and social media. The goal is to keep building a teaching platform that is practical, professional, and useful to the aviation community. This was a look at a class taught at Tropic Air in Belize on avionics basics, troubleshooting, and wire repair. More importantly, it is also the start of a broader Deep Blue Avionics teaching effort, one focused on practical aviation knowledge, structured training, and technical content that supports real maintenance work. If this kind of aviation education is useful to you, make sure to subscribe and follow along, because we will be sharing more classes and upcoming courses on YouTube and social media going forward.